A very good evening to all. A very good evening to all. Yeah, I think my voice is clear. So very good evening to all. Thank you for your presence in the masterclass. Today is day 19. Today we are gonna see stepper motor control. So we are gonna write a Verilog code for stepper motor to control the speed of stepper motor by using the counter and the clock. So then this is for today, and then tomorrow we will see the UART protocol. So how to write the RTL code and what is the design specification of your protocol, and then day after tomorrow we will see the on-chip protocol like APP or I2C. We will see in the upcoming classes. So today topic is stepper motor control using FPGA. So we have the MAX10 FPGA in my I have in my hand. So and then I have stepper motor, and then for control the stepper motor we having the driver. So driver I will show you in the end of session. So ULN 2003 driver, it is used for a stepper motor and a servo motor driving purpose. So very good evening to all. Thank you for your joining. So very good evening Bharat Singh, Sumit Kumar. So very good evening Hari Shankar. So let's wait for a few minutes. So Imuna, good evening. So I just show you what are the hardwares I am having currently now. So this is a driver. It's a driver for the stepper motor. So it having the ULN 2003 IC, and then I have a stepper motor here. So you can see a stepper motor here. So and then I have FPGA MAX10 FLK FPGA board. So with my USB blaster JTAG. So let's see how to write the RTL code for that. So basically we'll see what is a stepper motor. A stepper motor is a brushless electromechanical device that converts a series of electrical pulses. So it is the main point that it converts a series of electric pulse applied to its excitation windings into precious defines. It means so we are giving some. So every stepper motor it having the like a coil, like a winding. So we are giving them. We are giving some serial inputs like a serial pulses. Like if you stepper motor having the 4-bit 4 windings or 4 coil means, by using the 4-bit of serial pulses, electric pulses, we can control the step changing. So basically stepper motor will change by step process like so it is a there is some degree like 1.8. So this is 1.8 is a normal average degree. It will change to position. So it means it will move. So you can see that shaft, say like a rotating shaft, it will change a degree like 1.8 degree at every step. So each step it will change 1.8 degree. So if I continuously giving electric pulses for a stepper motor, it will change step by step. So with 1.8 degree changes, so I can see some rotation. So the stepper motor will rotate the 360 degree. So it is a continuous rotation. So how long you giving the electric pulses to stepper motor, it will rotate based on the degree. So we can change the degree also. So it's not a step size. So it is a degree, steps degree. So 1.8 degree each. If you give some electric pulse, it's like a basically stepper motor having the four windings like a four coils. So each coil is known as a step. So four step we having, each step it will change degree like a direction 1.8 degree. So if I'm giving continuously steps degrees like electric pulses, it will continuously rotating with degree changes of 1.8. So the step so for step changes we having some separate values like binaries. So if you have for unipolar stepper motor, it having four windings. So you can see here that these are the four windings like four coils. So for step 1 we have to give this binary like a high high low 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 high high. So for step 2 this kind of binary we have to give this 4 bit of binary to change the steps. So step 1 to step 2 step 3 step 4. So we have to give this step. So it will change degree at 1.8 degree. So and then this is the structure looks like the stepper motor. So for step changing, so we know that steps we have to change the step, then only we can rotate that like a shaft, this shaft. So let's say like a output like a stepper motor shaft. So if you want to rotate means we have to change the step. So change step means in RTL in the Verilog code we have to use counter. So based on the counter value I can change the step. If I how long, so based on the counter speed. So if it is counter counts slow means it will change the step very slowly. If my counter is counts fast, so it will change it will change the step very fastly. So based on the counter value it will change the steps. So based on the counter like a counter speed, if it is counts in high speed it will change the step very at the high speed based on the counter. So by using the counter in Verilog we can we can control the speed of the stepper motor. If I give the high frequency counter, it will it will rotate fastly. If I give low frequency mean it will rotate slowly. So let's see how we use the counter for speed control in stepper motor. So this is the stepper motor structure. So it having four coils. So each coil we have to give some electric pulses. So we are giving by using the binaries like a 4 bit of binary in our code. So let's move to the Intel Cortex Prime. So I'm going to write the RTL code. So and then for this driver, so I am using the stepper motor driver like a ULN 2003 driver circuit. So we have to give for that particular circuit we have to give four inputs from like a four inputs. It will come from FPGA out. So 4 coil input and then 5 volt direct 5 volt supply VCC and ground. So 5 volt VCC and ground we have to give from FPGA. So and then 4 coil inputs for stepper motor in the driver stepper motor driver. So and then we are going to create the new project. So I'm just creating my new project. Sorry. So and then my project name is stepper. So and then next, so I want to choose my FPGA board. So I know that 10M50 DAF 484C7G. So this is my FPGA, I can see here. So then click next. So I don't want to do simulation. So if you want to do means you can choose your simulator. So I just leave it at blank. and then click finish. So here I'm going to new file, like a Verilog file. So I'm gonna write the RTL code for my stepper motor. So I just detach my window. So my module name is stepper. So this is my module name, and then my inputs are, my input is firstly I'm given some explanation about input is clock. So output is we are our stepper motor is having the 4 windings, so 4 bit of sequence, so 3 down to 0, like a sequence out. So it will looks like a sequence, 4 bit of sequence of binary sequence out. So it's look like this only. So you can see here, if I want to for step 1 we have to give like this binary: high 1 1 0 0 0. High means 1, 0, low means 0, 0 1 1 0, and then 0 0 1 1, and then high 1 0 0 1. So we have to give these binaries for each winding. So each winding means each coil. So and then we'll move to this my input is clock. So my output is 3 bit of like a 4 bit of 3 down to 0. It's been 4 bit sequence out for my driver, stepper motor driver. So I'm gonna use this sequence out in my always block. For that I have to use registered reg keyword for this particular variable. So and then I have to give some I have to make some memory. So we having some sequence. So this is 0 0 1 1, like a 0 1 1 0. We having some step sequence we have to store into memory. So at every time changing the step, we call that we can call that particular memory location. So we can use that sequence. So for that I am creating memory where 3 down to 0, like a wire name is this memory name is like a sequence, step sequence. So and then it will store like this manner. So and then assign, I'm just using assign statement. Assign like a step sequence. So it having the 4 memory location. Each memory location we can store the 4 bit of data. So at the 0th memory location I'm just assigning. So what value is like a 4 bit of binary 0 0 1 1. So this is for step 1. So and then assign. So assign, so just copy this again. So here for this one is here, 3 here, then 2 here. So these are the 4 memory location in the step sequence memory. So and then here we have to give some binary. So sequence first, it's this is for coil 1. So and then this is for coil 2. For step 2, so it's like a step 2, it will act in the, so sorry, I just made mistake here. This is for step 1. See, for step 2, so I'm giving some electric pulses for my 4 coils inside my stepper motor. So for first to 0, for first and second coil I'm giving high. It means it will, our driver circuit will give the electric pulses to my stepper motor, so it will change degree. So and then 1100 and then like 0110. So this is my step 3. Step 4. So I created my assigns. So why I am using wire means, you can see here I am assigning, so I am using the continuous assignment. So if you are using some continuous assignment, we have to give some particular, this is a variable, so it's like a memory. So it is in the form of wire data type. Why? Because of I'm using in my continuous assignment. If you are using in continuous assignment, you have to give like a wire. So if I change to rates means I will get an error. So I will show you what I will get. So I just save and run this to check this. You can see here I get an error. So you can see here Verilog HDL continuous assignment error at stepper V10. So Verilog 10th line here. So this is 10th line. What is it? Object step sequence on left hand side, continuous assignment must have a net data type. So net data type is nothing but wire. So left hand side, so this is left hand side, it must be, if you are using the assign segment, your left hand, so LHS must be in the form of like a net data type. So net means wire data type. So that's why I used wire here. So if you are using continuous assignment, so your left hand side must be in the wire type, so wire data type. So I just compile this again. So there is the no error. So I think I just wait for compilation done, completion. Yeah, you can see here I didn't get any error. So and then, so it's for if you guys are really interested in this master class, you can convert into the 1 month internship on FPGA design. So these are the benefits you will get from that internship program: all the details recording session, all the details presentation, exclusive project codes, VIP community group for your doubt clearing and internship updates. So and then you will get the internship confirmation letter from IETE. So and then you will get the 90 days LMS course access. So assignment task we are providing. So and then you will get the weekly live session for your doubt clearing. So we are giving some resume building ideas, mock test. So and then you will get the internship certificate and also participation certificate from the internship program. So this is amount, so this is a discounted fee of our internship program, just 999. So if you guys are really interested, you can avail it. So our regular fee is 3999. So in this session period we are providing at a discounted fee of just 999. So by using this registration link, you can use it. So you can get the link in chat box also, live chat box. By using the link you can register for the internship program. So this limited time period offer, it will close at 4th March, like 5th March, sorry 5th April. So let's move to so we did assignment. So I'm storing this sequence of binaries. I'm storing this sequence of binaries in my memory. So and then I have to give I have to control my step changing. For that I'm using always passage of clock. I'm going to write the logic for that. So link is not opening. So I think by using you can see the link in chat box, right? Chat box. So we will post the registration link for internship. We can use also. So I think our organization will post the link as soon as possible. So use that link, you can register for internship program. So let's move to the begin end. So here, so firstly, if I want to count my so I have to use delay for step changing. So like I'm going to use counter. For that I'm going to use counter. First I have to register for counter. So counter means so it will count 626 down to 0. Why? Because of you know that my as last class also we seen our FPGA board, it having 50 MHz clock. So it will count for 1 second up to 5 crore times. So for that counting purpose 5 crore times, we have to give that much bit range, so like a 27 bit. So 2 per 27 means you can calculate. So that much value it will count. So I will inform my organizer. He will post the link on chat box. So after the class also you can get in comments. So registration link for internship. So and then so I think some technical issues there for attendance link. So we will post the link after the class also in the same live comments. So sorry for that. So let's get into session. So for counter, it's like a step counter. So and then so I have to change my index. So I'm going to use my another variable is a step index. Step index. So why I'm using index means I will tell you. So here, so step counter if the step counter reaches like if step counter reaches like 25 lakhs, 25,000, and then 2 lakhs, so 2 lakhs 50,000, so 25 lakhs I think so. So 25 lakhs, if my counter reaches the 25 lakhs, so 25 lakh count, I'm just reset my counter step counter equal to 0. So and then so I'm just and then I'm changing my step index. So even yesterday we didn't so yeah, sorry for that. You will get the both attendance from today and last day also. We will post the attendance in the comment box after the live session. sorry for that. So I'm just increase my step index, like a step index +1. So if my counter reaches this much value, I just reset my counter. I'm assigning. So why I'm using this value means at every 25 lakhs counts I will change my index. So I will change my index means in my memory I'm changing my index. So it will each and every memory location it having some binary values for my coil. So it will assign that particular binaries to my sequence out. So I'm gonna write this logic. So for that I'm just changing my index. It means increasing the index. So it will index start from 0. So and then step counter also start from 0. So and then begin end else. So don't worry about that. So we will provide the link after the session. So begin end. So index 21. So after that so and then after or else if it is fails means it will comes here else condition. I'm just increasing my step counter. I'm using non-blocking here to reduce my resonant condition from signals. So and then step counter +1. So and then so this is the if it is fails it will come here and then it will increase the count. So if it is reaches this, if it is true means. So and then there is another thing in assignments like so if I'm using double equal symbol, it's like a logical equal. If I'm using triple equal means it's like a bitwise equal assignments. It means it will check. So if I'm using this means it will check both variable having same values, like both are high or some true conditions. So if it is if I'm using here, this means it will check x and z. So x means unknown value and then z means high impedance. It will check both all the 4 state. So we know that so reg having the 4 state like a 0 1 4 state reg like a 0 1 x and z. X means unknown, z means high impedance. So if I'm using 3 equal sign means it will check all these states like a 0 1 z and x. If I'm using this means it will check only 0 or 1. So this is a logical equal operation. So if I'm using this means it will check up to 4 states like a 0 1 x and z. So and then link is not configured properly, please correct. Yeah, okay, we will correct that issue. So hereafter we will give the correct link on a time. So and then sequence out. So I'm going to assign my seq output for output sequence out equal to. So here step sequence, and then inside the bracket step index. So it means, so you can see here step sequence is in my memory. So step index, so you can see here I'm just increasing my step index here. So at every 25 lakh count, I'm just increasing my step index. So initially it having 0. So on that step sequence of 0 means here this is a step sequence of 0. It having this binary, it will assign to the sequence out. So don't worry about that link. So we will post the link on chat box after the live session. So and then this is that module, this is the working of this. So and then step index, if it is increased to 0 to 1, 1 means step sequence of 1. So it means this binary sequence will assign to the sequence out. So sequence out. So this is the RTL code for the. So based on this I am just increasing my step index, and also and also the and also I'm also increasing my step counter. So you can see, so this is RTL code for that. So I'm just increasing my step index at every step counter. So step counter will count up to 25 lakhs. So every 25 lakh count, I'm just increasing my step, like a first step, second step, third step, fourth step. It means I'm giving the 4 steps for the my stepper motor. It will based on my step inputs only, it will rotate. So this is RTL code for that. I just compile this. So and then I'm going to assign the pins for my circuit. So my clock, it having the E11, I know that. So I already did pin assignment for another project. So if I do means, so I have to go for my schematic and then I have to find pin. So it will take some time. It will take some time, like so I have to go for the schematics. So I have to find each and every pins. So it will take some time. For that reason, I already did project same code. So I'm gonna use that. So the code is here. So this is the project I already pin assigned. So you can see here I already given some pin numbers for my signals. So you can see here I having the 4 outputs, like a sequence out. So it is like a step 1, step 2, step 3, step 3, and then clock input. So I'm having the 4 outputs and 1 clock input, and then I'm just compile this again. Yeah, don't worry about that attendance link. We will post the link on comments after the live session. You can use that. You can use for your register or link, register your attendance. So and then then I just open my programmer, and then this is my programmer. Then click on it, and then change file. In my output files I having a SOF file. Just open it, and then click here program and configure, and then click on start. So you can see here my so I will show you that stepper motor rotating. Just a minute. Yeah, you can. So you can see here the stepper motor rotating. So this is a driver circuit. So this is a driver circuit for my stepper motor. I hope it is visible for you. So this is a stepper motor. It's rotating. So I just use some plastic, like a sheet, to see my output. So you can see here this. You can see these 4 LEDs. It is blinking very fastly. So this is high speed of a stepper motor. If I increase the more speed, It means if I reduce a counter value, I can't see the rotation of the stepper motor, right? Because of if I give the high frequency input for stepper motor, it will stick. So this is the output for stepper motor. So it will rotating. So this is FEJ. I just connected my FEJ and equivalent driver, so stepper motor driver by using the jumper cable. So in this stepper motor driver, it having the 5 volt VCC and ground, and then four, you can see these 4 lines here, four wires for like I already said, 4 outputs, like 4 steps. So these the 4 steps for output wires. So and then I will reduce my speed. So how means if I want to reduce my speed means I just increase my counter value. If I increase my counter value, so it will change step to each step very slowly. So by using this, so step size and how to define the stepper motor driver in order, or it is not required. So each stepper motor is having some coils, like a 4 windings. So based on the windings only, we can consider it. We can use the steps. So if in this my stepper motor is having the 4 windings, so I can use for 4 steps. So it having 4 steps only in my stepper motor. For that I'm using the 4 bit of sequence out. So and then if I increase my counter value, so based on the counter, by increase my counter constraints, I can reduce my speed of stepper motor. I just save and compile again. So it's doing compilation, so just wait for a few minutes. So and then I'm going to programmer and then click and then change file. I just program my new SO file to my FEJ. So and then click on so and then you can see here. So and then sorry for that. So you can see here the stepper motor rotating very slowly. Why? Because I'm just increased my counter value. So if my increase means I can reduce my stepper motor speed. You can notice here it will rotate slowly, and also you can see the LED blinking also blinks very slowly compared to previous one. So this is a way of writing the RTL code, and we can reduce the speed of the stepper motor by using the counter. So basically counter is very important thing in RTL, so Verilog. So we can give the delay. So while writing RTL code, mostly we are using the clock and the counters only to give the delay. For verification purpose, we are using some testbench and giving some delays. So this is for today. So don't worry about that attendance link. We will post the link after the session on the same video comment box. So we will post the link on comment box. So thank you guys, thank you for presence, thank you for listening. So we will post the link on comment box after the session. So thank you. we'll see tomorrow with the UART protocol. So and then I want to share one thing. So I received query about why UART uses why UART don't use the clock, like a why can't we use the clock for UART? Why? Because of, if I am using the clock means the transmitter device and then receiver device must have the clock to make the synchronization. So this is a big reason why you are don't use the clock. So without clock we can communicate from one device to like a microcontroller to peripheral device. So if you imagine, if your peripheral device don't have the clock means, uh, so if your peripheral device don't have the clock means you can't make the communication between microcontroller and a peripheral device if you are using clock for UART. So for that reason only we didn't use UART, we didn't use clock for UART. So it is asynchronous, so we can make communication by using the baud rate. So baud rate and the start bit and the stop bit, like kind of things. So this is the main reason why we didn't use clock for UART. So why it is called as synchronous, this is the reason for that. So let's see tomorrow with UART. Thank you guys.